A little bit of history here. A goal-back number is a positive even integer that can be expressed as the sum of two odd prime numbers. Prove that every even number from 6 to 40 is the sum of two odd primes, i.e. all the numbers from 6 to 40, even numbers, are about a goal-back number. Now, a goal-back conjecture is one of the oldest and best known unsolved problems in number theory. We're only going to prove it's true for 6 and to 40. However, we can use what's known as proof by exhaustion to show that the conjecture is true for 6 to 40. What we mean by proof by exhaustion is that we're going to try every case from 6 to 40. So 6 can be written as 3 plus 3, two prime numbers. It doesn't have to be distinct, and they are both odd. Okay. Now, technically speaking, this is known as a goal-back partition. This is a technical term. 8 is 3 plus 5. Now, have I done two examples? You might like to now stop the video and write out all the other even numbers out to 40 and see if you can express them as two odd primes. Okay, i.e. you cannot use the number 2 because it's an even prime. 10 is 5 plus 5. 12 is 5 plus 7. 14 is 7 plus 7. 16 is 5 plus 11. 18 is 7 plus 11. 20 is 7 plus 13. 22 is 11 plus 11. 24 is 11 plus 13. 26 is 13 plus 13. 28 is 11 plus 17. 30 is 13 plus 17. 32 is 3 plus 29. 34 is 17 plus 17. 36 is 13 plus 23. 38 is 19 plus 19. And 40 is 17 plus 20. 40 is 17 plus 23. Now, we've proved it for all the even numbers between 6 and 40. We've been able to express them as the sum of two odd prime numbers, i.e. we haven't used number 2, which is the only even prime number. And remember, a prime number is a number it has two distinct factors, namely 1 and itself. 1 is not a prime number, and therefore we've actually proved this by what's known as exhaustion, because we've actually proved it true for every case. Therefore, we can say this statement here or conjecture here has been shown true for every case. Therefore, it's proved. This is the idea of proof by exhaustion. You try every case. Okay, I hope you've understood the concept of proof by exhaustion. And I thank you very much for watching.